Very good morning. Today now I am going to discuss about carbon dioxide laser. Actually, in last class I already discussed about that is the types of lasers. And the types of lasers, gas lasers are there. And the gas lasers in last class now I already completed helium neon laser. Now in this session now I am going to discuss about one more type of the gas laser, that is carbon dioxide laser. Okay, first now I am going to the carbon dioxide laser, introduction of carbon dioxide laser. Here coming to carbon dioxide laser, in ruby laser, in ruby laser and that helium neon laser, when we are considering that ruby and the helium neon lasers, previous lasers, the transitions are taking place among the various excited electronic states of the atoms or an ion. Transitions are takes place excited by the excited electronic states of atom or any ions. Okay na? Now but here in this carbon dioxide laser, the transitions are occurring between the different vibrational states of the carbon dioxide molecules. Okay na? Where there excitation of electrons, electronic states of the atoms or ions. Here the excitations is occurring between the vibrations of the particular carbon dioxide molecules. That is the main difference of previous one, whatever the lasers we are discussed in previous sessions, that and this one, that means carbon dioxide laser. Okay, in this carbon dioxide laser, yeah, in this carbon dioxide laser, high power of carbon dioxide lasers can find applications in the material processing. What is the special? What is these are the special features of carbon dioxide lasers. Now, these carbon dioxide lasers are we are using in the material processing and the welding and the hole drilling and the cutting purpose. We are using this carbon dioxide laser, high power carbon dioxide laser. Now, one more main feature of this carbon dioxide laser is the atmospheric attenuation is at low. That is how much of 10.6 micrometer. Okay, na? Carbon dioxide lasers are also used in open air communication. Also we are using this carbon dioxide laser. And one more thing is it is used in surgery applications, where in medical application, that means medically where we are using in surgery as a direct substitution of what is substitution for a scalpel. We are using as we are substitution in the place of where we are removing a particular any objecting on the human body, any small objecting in the human body, for the removing purpose we are using this carbon dioxide laser. Now laser radar or lidar means that is a light detection and ranging, as provided to be a powerful tool for investigation of variety of atmospheric features. What are the atmospheric features? Now you have to find in the atmospheric pollutants concentration, ozone concentration, water vapor in the air concentration purpose. We are using this carbon dioxide lasers. That's why these are the main special features are we are having in carbon dioxide lasers. Okay. Now coming to principle of carbon dioxide laser. What is the basic principle we are using in carbon dioxide laser? Here actually a carbon dioxide CO2 laser is a 4-level laser. Okay na? It is a 4-level laser. For the laser action, two points are important. One is what is the population inversion between the two levels, and second one is increased density of incident radiation. Increased density of incident radiation. These are the two important. Principle of the carbon dioxide laser is transition, where the molecules transition between the between vibrational states of the same electric state by achieving population inversion between these states. Okay na? Population here, how we are getting the laser action, laser beam output. transition of or excitation, how we are getting the excitation of particular molecules due to the vibration of the particular molecules. Okay, na? Vibration of the particular molecules. Due to the vibration of the particular molecules, we are getting the population inversion. Okay. Now, laser structure and discharge mechanism. How the laser is there? Carbon dioxide laser. It consisting of actually here the size of the laser. Here this is carbon dioxide schematic of the laser. It's consisting of here. This is the one laser tube. Okay, na? Here in this laser, what is this? It is the inbuilt of that laser in this tube, in the cylindrical structure. We have to fill with this carbon dioxide, helium, and neon. Okay, na? And here there are the for the gassing purpose inlet is the gas inlet, and gas discharging purpose gas outlet is there, and one Brewster window is there. Here we can place here one Brewster window. And now the purpose of the Brewster window, to get the total internal reflection purpose, we are using the Brewster window. And here there are, this is Brewster window. Here this is Brewster window actually. Here also one Brewster window is there, but it is not shown there, that Brewster window. Okay, whenever we are applying, whenever the atoms molecules are excited, it will move to the partially reflected mirror only. Here this is the fully reflected mirror, this is partially reflected mirror. When the laser beam, when the laser light is we are getting some any laser beam output, there may be chance of heating problem. To control or to monitoring the particular this total setup, now we have to supply continuously supplying a cooling. One coolant action is, one coolant is also we require. And the coolant action we are supplying, we are giving when we are giving input for water purpose, there is water input, and we are getting some heat output, water output. Okay, this is the basic schematic of carbon dioxide laser. In this carbon dioxide laser, yeah, it's consisting of a discharge tube. What is this discharge tube? Yeah, this is a discharge tube. Here, this is a discharge tube. This is totally, this is a discharge tube. Here, it's consisting of the length of the discharging tube is size 2.5 centimeters in diameter and 5 centimeters in length. Okay, na? The 2.5 centimeters in diameter and the 5 centimeters in the length. The optically plane and parallel mirrors are there. One is completely reflected mirror, one is partially reflected mirror. And the discharge tube is filled with the combination, I already told. Now what is this? The discharge tube is filled with the combination of carbon dioxide and nitrogen and helium gases at the pressure of a few mm of mercury. At the pressure, we have to fill the particular cylinder. We have to fill the particular discharge tube with the combination of the CO2, N2 and helium with the pressure of few mm of mercury. A high value of now whenever we are filling that helium and neon and carbon dioxide, the carbon dioxide atoms are does not excited themselves. Okay, na? For the excitation purpose, we have to give some supply voltage for some DC voltage. Okay, na? Whenever now a high value of DC voltage is used for electric discharge in the tube, due to which carbon dioxide molecule breaks into the breaks into carbon, CO and O, oxygen. That means carbon and oxygen. So periodic replacement of gas is required, and oxygen can corrode the electrodes. For breaking of our the CO2 into in the form of carbon and oxide, now we are using the high voltage of DC voltage. Okay, it's applying the high voltage of DC voltage. This is the structure. And now the discharging mechanism, how the molecules are discharging. This is the general setup for the discharge mechanism in helium carbon dioxide laser. In this carbon dioxide laser, it is a combination of actually here this is a CO, helium, carbon dioxide, neon is there, and one regulator is there, and this is the gauge. Now when we are giving this input with some pressure, okay, na? We have to control the particular pressure also by we are monitoring the pressure by using this gauge. Now this is the in this cylindrical rod we have to fill this three gases. Now here the discharging tube, here we are in this then some vacuum pump is there, and rectifier block is there, high voltage rectifier block is there, and our transformer is one power supply unit is there, and power distribution panel is there. Okay, na? This is the total setup for the discharging tube. For to control, to monitoring, to control the tube temperature, we have to one coolant, that is water pump system is there. Okay, na? To power distribution panel. This is the general discharging tube setup. Now, actually, carbon dioxide laser, one of the most powerful and efficient laser. This is okay. This is a 4-level laser. It operates on a set of vibrational and rotational transitions. Vibrational and rotational transition. Okay, na? It operates. Output in the range, infrared region only. We are getting some output at the range of 10.6 micrometer to 9.6 micrometers. Here, actually, the output is we are getting in pulsed mode output. Here, continuous or pulsed mode output. But the pulsed mode output is a very strong. We are getting some very strong output. Okay. Now that output, both that we are getting continuous or pulsed output modes output. Continuous mode power output, it always greater than 100 kilowatts, and pulse should energize as much as 10 kilojoules. Okay. Next, laser energy levels of carbon dioxide molecules. Here, how the operation, before now I am going to that operation, working of this carbon dioxide laser, energy level. Now I am going to discuss about the energy levels. Okay, energy spectrum of the molecules complex. Okay, complex, and it includes many additional features. Each electron level associated with number of vibrational levels. Each electron level here, it is associated with the number of vibrational levels, and each vibrational level in turn has a number of rotational levels. First of all, it is when the CO2 atoms are vibrating, after vibration it is rotating. Okay. Now, CO2 molecules, a linear molecules consisting of central carbon atom with 2 oxygen link, one on either side. One on either side. Okay, these are the energy levels. Now, how the carbon dioxide can undergo 3 independent vibrations, oscillations are there in a vibration modes. So what are the vibration modes? Vibration modes are there. Here there are the first vibration mode is strength mode. Okay, na? And second mode is strength mode, that is also called the symmetrical mode. Strength or symmetrical mode, and second one is bending mode, and third one is asymmetrical mode. In strength mode, how a carbon and oxygen atoms are moving. In strength mode, when we are in strength, when I am applying any strength of the particular CO, it is moves the oxygen atoms in the form of a symmetrical mode. Okay, na? When I am applying in the coming to the bending mode, when I am applying some any bending action, now the atoms are moves like this in perpendicular, in parallelly the oxygen atoms and carbon dioxide atoms are, it moves, vibrations are arise in the parallel. Coming to the asymmetrical mode, in asymmetrical mode, due to the vibrations, the molecules are moves either from like this. Okay, like this are asymmetrical mode. Either there is no similarities of the particular carbon and oxygen molecules. These are the 3 modes: strengthening mode and bending mode and asymmetric strengthening mode. Okay, na? Each mode is quantized. Molecules can have 0, 1, 2, 3 units of vibrational energy in each mode. At any one time, CO2 molecules can vibrate in any linear combination of 3 modes. Okay, na? That may be any linear combination of 3 modes. Either that is strengthening, bending, or asymmetric, or the symmetric, bending, or asymmetric. Okay, each energy state represented by 3 quantum numbers. Each energy states are here. In previously we have to discuss that what is the energy state, energy level E1, E2, E3, E and E4. Now here each energy state that represented with the quantum numbers. What are the quantum numbers? M and N, M and Q. Okay, na? These numbers represent the amount of energy associated with each mode. Here, if suppose M is there, that M it is represented the how much of the amount is amount of the energy associated with the particular mode. Okay. Now 0 from the 0 to 1, that is the pure bending mode with the 2 units of energy. Okay. Now each vibrational state associated with the rotational states corresponds to rotation of a molecules about its center of mass. Now much smaller energy separation between the vibrational and rotational states. Here this is the basic schematic structure of our carbon dioxide laser. It's consisting of this tube. Okay, na? In this tube we are having one blister window, and these are the external mirrors. Partial fully reflected mirror, this is the partially reflected mirror. Then we are giving the supply. Here for the gas input we are giving gas input of helium, neon and carbon dioxide, and gas output of one output. Okay. Now to controlling this totally heat controlling purpose, we are giving water supply inlet. Okay, this is the structure. Now the discharge tube, that is having, I already discussed this one. The discharge tube having the bore of cross section of 1.5 centimeters and length is 25 centimeters. Tube is filled with a mixture of carbon dioxide, nitrogen and helium gases. A high voltage DC is applied for the dielectric electric discharge to pass through the tube. Discharge breaks down carbon dioxide molecules to O and oxygen and carbon dioxide. A small amount of the water vapor added to the gaseous mixture to regenerate the carbon dioxide gases. Now coming to the working. How it's working a particular this carbon dioxide lasers. The vibrational or rotational modes of the carbon dioxide cannot be excited themselves. Okay, na? Cannot be excited themselves. That's why we have to add by themselves by photons by optical pumping. That's why we have to add in some external gases. What are the external gases? Neon and helium. Or we are adding when we are mixing this neon and helium gases, then only the molecules are excited to lower level to higher level. Okay, na? When a voltage is placed across the gas, electrons collide with the nitrogen molecules, and when the voltage is applied, supply voltage is applied, the molecules, the electrons collide with the nitrogen molecules and excite to their vibrational levels. When it is vibration, then only we are getting some output. Okay, these vibration levels happen to be at an energy very close to the energy, the asymmetrical vibration states in the carbon dioxide molecule. First it reaches to the asymmetric energy level. From that asymmetric energy level, now the excited nitrogen ion molecules populates the asymmetric vibrational states in the carbon dioxide molecules through collision. Okay, here this is first when supply voltages we are giving, high voltage DC voltages we are giving. Here the electrons collide with the nitrogen molecules. When the electrons are collide with the nitrogen molecules, here electrons are collide with the nitrogen molecules, the neon atoms are goes to the higher energy level. The neon atoms are goes to the higher energy level at the symmetrical strength, at the asymmetrical higher level state. From the higher asymmetrical higher level, now the molecules are falling down to the next state in the bending state and the symmetrical state. This is neon atoms. Okay, na? This is the carbon dioxide energy level, the energy transition diagram. Now initially, now when nitrogen ions are molecules are it goes to the energy level from the ground level to the higher level. When the electrons collide with the asymmetry, in this first position nitrogen ions are collision with these electrons then in this position asymmetrical strengthening is there, where the asymmetrical strengthening is done after the ions or the molecules of carbon dioxide, it falls down from the asymmetrical to the next state, symmetrical state. Next step, that is the symmetrical state. Here in this population inversion is we are achieved, in this we are getting some laser beam output. Now after that fast decaying, then the molecules are falling down to the fast decay to the ground level. It falling down to the ground level. Okay. Now output, how we are getting that output? The output is in the form of, we are getting in infrared output of the lasers is the result of transition between the rotational states of the carbon dioxide molecules of the first asymmetrical vibrational mode to rotational state of the both of the first symmetric strength mode and second bending mode. Second one is bending mode. First it will goes to the asymmetrical, then it will goes to the symmetrical, then after that bending mode. Here this is energy levels of carbon dioxide and nitrogen molecules transition between the levels. First nitrogen molecules are goes from the lower level to the higher level. In this higher level state is energy transition through the collision. In this the level is 001. Okay na, that 001. Actually this carbon dioxide laser, it can form the, it is a 4 level laser. In this 4 level laser, here it can form the higher level is, that is the 001. Then due to the population inversion, the molecules, whatever the molecules are there, it can falling down to the E4 and E3. In this E4 and E3 we are getting some laser beam output due to the population inversion. We are getting some laser beam output at with a wavelength of 10.6 micrometers and 9.5 micrometers. Okay na? Here in 10.6 micrometer output we are getting in 100 level, and in 9.6 micrometer output we are getting here 0 to 0 level. After here in this, actually even here E4 and E3 are, we are these are acts as a metastable state. Then after that it will stays some time of the molecules, it falls down to the lower level E2 and E1. Then again the process is continuous. Okay. In carbon dioxide laser, N2 nitrogen, it can plays the same role as helium in helium neon laser. Lowest vibrational levels of nitrogen have nearly the same energy as asymmetrical mode of carbon dioxide. Now it's really transfer of energy by the nitrogen to carbon dioxide molecules in resonant collision. Carbon dioxide molecules excited to 001, that is E5 level. Here always E4 and E3 that acts as the metastable state. And population inversion is established between the E5 and E4 level and E5 and E3 level. Here the population inversion is achieved, we are getting in from E5 and E4 and E5 and E3 levels only. Okay na? Now the lasing beam output, where the molecules are falling down from the E5 to E4, we are getting some laser beam output at 10,600 nanometers, and when the molecules are falling down from the E5 to E3, we are getting some laser beam output 9,600 nanometers output. Okay. Next, carbon dioxide molecules at E4 and E3 draws to E2 through the inelastic collision with helium atoms. Okay na? In elastic collision with helium atoms. Why we are using this helium atoms? Because of where after molecules are falling down from here to here, then again it can fall down from the E3 to E1 or E3 to E2. We are using this helium ions. Okay na? We are using this helium ion. Decay from helium energy level to ground state to be very fast. Accumulation leads to decreases in population inversion. Helium atoms helps to depopulate level E2 through collision. Okay, E2 level very close to ground state, it tends to populate by the thermal excitations, then necessary to keep the temperature of CO2 low. How we are CO2 low? By supplying the water. It has high thermal conductivity of conduct heat away to walls to keep the CO2 cool. Next, in CO2 lasers, nitrogen helps. What is the purpose of the nitrogen? Helps to increase the population of upper laser level, whereas helium depopulate the lower level laser, lower level energy level. Available in different configurations and varying output powers. It is available in different configuration with varying output powers. Coming to the applications of carbon dioxide laser, the main advantages of the carbon dioxide laser is we are using this in drilling and what is this, in drilling and welding purpose we are using this, and medical applications also we are using carbon dioxide laser. And here these are applications that very intense to heating source can be applied to a very small area. Okay, na? For the particular small area for the heating purpose of that purpose we are using this carbon dioxide laser. Because of the high power of carbon dioxide laser are frequently used in industrial application for the cutting and welding. Okay, na? They are also very useful in the surgical procedures because of the water absorbs this frequency of light very well. Okay, some examples of medical uses are laser surgery, skin surgery purpose also we are using this carbon dioxide lasers. With this carbon dioxide lasers are completed. In next session I am going to that one more type of the laser. Thank you.